Hello everyone, so my name is Tuan and today I'm going to talk about our project, IZA, an intelligent shopping assistant. So this is a joint work with Dr. Chung and Dr. Nadim from Adobe Research. So shopping in a physical store is still a popular choice for many people. And so in this work, we introduce IZA, an intelligent shopping assistant that is designed to improve the shopping experience in a physical store. So suppose you are a customer in a shopping mall and you see a product of interest, then you can simply take out your phone to take a picture or scan the barcode of that product. And then the assistant will use some kind of computer vision techniques to recognize that product. And after that, you can start asking natural language questions about the product to the app. And after talking to the assistant, if you like that product, you can make the purchase decision inside the app. Or if you don't like the product, we also have implemented the recommendation features so that the assistant can recommend you some other similar items. So we have prepared a video that briefly explains the motivation and also the overall features of our assistant. I will show you that video now.
Shopping in physical stores is still a popular option for many customers. For retailers, it is important to provide good customer experience at a brick-and-mortar location. Very often, a customer would ask a shopping associate for help before making a purchase decision in store. But sometimes the number of shopping associates might be limited and the amount of product information might be large. The goal of this project is to enable retailers to provide better in-store customer help service.
How much is this?
The price is $79.79 each.
Can I return this product if I think I don't like it?
The product can be returned within 90 days of the original purchase date of the product.
How heavy is this? Can I carry it?
The product weight, lb, is 28.
So this is the overview of our system. So there is a front end inside the user's mobile phone. And this front end is talking to a back end through REST APIs. So the back end is actually the brain of our assistant. So the back end consists of three main components: computer vision, speech processing, and natural language processing. So in this presentation, I will just briefly describe the computer vision and speech processing components. I will focus more on the natural language processing components. So this backend is also connected to a product database, so that if the backend needs the information of some product, it can retrieve that information easily. So the first component is the speech processing component. So users can talk to IZA using voice just like talking to a real human. So there are two subcomponents: speech recognition and speech synthesis. So we implement these subcomponents by using third-party APIs. So the next component is the computer vision component. So we have implemented a product class recognition model. So it will take an image from the user as input, and it will try to recognize what is the product in that image. However, in a shopping mall, there can be many different products. So even the state-of-the-art model can have some difficulty when trying to recognize the product from a single image. Therefore, to tackle this issue, we also implement another subcomponent called the barcode recognition component. So when the product class recognition model is uncertain, the user can then just simply scan the barcode of the product of interest, and then the assistant will be able to automatically determine what is the product. So now I will talk more about the natural language processing component. So when the assistant receives a natural language input from the user, it will first run an intent recognition module to determine the intent of the user. And then based on the recognized intent, the appropriate domain-specific engine will be triggered. So we define 4 different types of intent. The first one is called product information question answering. So this is for when the user wants to know more information about the product. The second intent is called purchase. So this is for when the user explicitly says that he or she wants to buy the current product. The third intent is called recommendations. So this is when the user want to see some other similar items. So in this case, our assistant will recommend some other products to the user. And the last intent is called chit chat. So this is for when the user says something that is not really relevant to the product. That can be something like just greetings, like hello, how are you? So for intent classification, we created a data set of 500 different queries and used this data set to train a random forest model. So the input to the random forest model is simply a bag of wood feature vector. So despite the simplicity of this approach, we achieve a test set accuracy of 98.2%. So it is very accurate. So depending on the recognized intent of the user query, different engine will be used. For example, the chit-chat engine is used to reply to greeting queries or queries that are not really relevant to the product, like hello, how are you, or how are you doing, how have you been. So our approach to building this chit-chat engine is based on the sequence-to-sequence framework. We collect about 6 million query response pairs from Reddit and use them to train the sequence-to-sequence model. So the sequence-to-sequence framework consists of an encoder and a decoder. So the encoder takes the input query as input and encode them into vectors. The decoder uses the vectors to generate a response. So here are some example outputs of our chit-chat engine. For example, when the user says, how are you today, my friend? The assistant will reply, very good. Or when the user says, you are very smart, the assistant will say, thank you. Or when you say, you are very stupid, the assistant will say, no, I'm not. So next, I will talk about the product information question answering engine. So this is one of the main engines of our assistant. So we formulate the question answering task as the answer selection problem. So for every product, we basically have a list of specification stored in the database. And then given the question, the main task is basically find the specification that is most relevant to the question. So I have an example here. So suppose the user is talking to the app about a chair, and then this chair has a list of specification and also the corresponding values. And then given questions, can I return this chair later if I do not want to use this anymore? Then we use an answer selection module to determine that the returnable specification is the most relevant to this question. And from this retrieved specification, we generate the final response using some type of template. So we collect a data set of about 7,000 question specification pairs using Amazon Mechanical Turk. And then we implemented the I1 model. So it was one of the state-of-the-art sentence matching model and is used to achieve state-of-the-art performance on several answer selection data sets. So when we use this model, the top one accuracy is about 85.6%. The top two accuracy is 95%. So it's very good. Thank you for listening.